Hi class, this is Professor Lazarus. I just wanted to take a moment in this video to go over a couple of questions one of your classmates had. And they're from section 8.4, and we're using some of our techniques from 8.4 and also 8.2 for these two problems. So the first problem right here, we're taking the definite integral from 0 to 1/6 of dx of 36x squared plus 1 to the 3/2 power. So as you learned in section 8.4, you want to set up your little right triangle. And if you have a plus in here, we know that that's going to be the hypotenuse. And then we want to use tangent, right? We're going to use tangent for that one. But here, I've got the 36x squared. So if I take the square root of that, I get 6x. So that's what we have right here. In fact, I can write that down for you. So this right here is the square root of 36x squared. And technically, the square root is the absolute value, but we know that it has to be positive anyways because it's the length leg of the triangle. So that's where we get that one from. And then this is just the square root of 1 is just 1 right here. Okay. And I guess I'll go ahead and write that for you too, just in case you need that. Alrighty. Okay. So we draw our triangle out. And then as we did in class, we'll go ahead and write down everything that we're going to need. We want to make these trigonometric substitutions where we only have theta in our expression. So you can kind of, since I've already done the work ahead of time and I'm just kind of explaining it here, you can see that we're going to have theta down here. So we don't want to have any x's. So that's what all this side work is over here. So we have tangent theta is 6x over 1, right? Opposite over adjacent. So 6x over 1, which is just 6x. And then we want to solve for x. So we divide 6 to the other side, and I get x equals 1/6 tangent theta. And so then our next step is to find the differential dx. So dx is going to be 1/6. The derivative of tangent theta is secant squared theta, and then d theta. So that's what we have there. Next, we already did our substitution where we're using the legs of the right triangle. Next, we want to find out what this hypotenuse is going to be. So the simplest thing would be just to use the one that we have right here. And so I could either do 1 over the square root of 36x squared plus 1, and that would be cosine, right? Cosine's the adjacent over the hypotenuse. Or I could make it a little simpler and do the hypotenuse divided by the adjacent, which is secant, right? The reciprocal of cosine. So that's what we're going to do here. So the square root of 36x squared plus 1 divided by 1 is just this right here. So square root of 36x squared plus 1. Next, we're going to need to, since we are going to be substituting theta for x, right here we have our x, our lower limit of our integration, which is 0, and that's an x value. Then we have our upper limit right here, which is 1/6. That is also an x value. So we want to change these into theta. So that's where you see the work right here. We know that tangent theta is 6x. If I want to find theta, I just need to take the inverse of both sides of this. So when I do that, I guess I can show you the work here too, just in case anybody needs to see it. So I have tangent theta equals 6x. Okay. I can take the inverse tangent of both sides. Okay, and when I do that, the tangent and the inverse tangent cancel. This is a composite right here. And so we're just left with theta is equal to inverse tan of 6x. Which is what we see written down here. So with that, we can go ahead and change these limits right here from 0 and 1/6 to whatever they are in theta values. So for the first one, we're going to have theta 1. The lower limit is going to be inverse tangent of 6 times 0. So we're plugging it into this equation here. So our lower limit was an x value of 0. So plug that in. And tangent of 0 is actually 0. So this is just inverse tangent of 0 is going to be equal to 0 because tangent of 0 is 0. So in this case, remember that if we're doing the inverse tangent, we're trying to find the angle that creates the ratio of 0. So 6 times 0 is 0. So our input here will be a ratio, and we're trying to find the angle. Okay, so it's going to be 0 radians. And then our next one here, this is going to be for our limit that's up here. When we plug in 1/6, 6 times 1/6 is just 1. So for our ratio to be 1, that means that the x and y values need to be the same. We know that on the unit circle. That occurs at pi over 4, at least within the range that we have for inverse tan. And so that's the angle that we're going to have. If you're not sure about that, you need to make sure to go ahead and review your unit circle. So here's a unit circle that I pulled up off the internet. Remember that tangent is sine over cosine. So we're taking the y value that you have here and dividing by the x value. Either way, if I want to find what angle makes it equal to 1, well, that means the x and y value need to be the same. That happens at pi over 4. It also happens at 5 pi over 4, and really any of the rotations that land in the same spot. But if you remember, for inverse tangent, it's restricted from negative pi over 2, which is the same location as 3 pi over 2, all the way to pi over 2. So, so it's just going to be pi over 4 then. That'll be our angle that gives a tangent value of 1. So in other words, inverse tangent of 1 is equal to pi over 4. And that's what we see down here. Okay. Let's go ahead and just show you here too. Remember that inverse tangent is restricted from negative pi over 2 to pi over 2. And so we're looking for when our tangent value is 0. Well, again, the tangent is sine over cosine, and that's only going to occur right here at 0 radians, right? Because if I take the sine value 0 and divide by 1, I get 0. So since tangent of 0 is equal to 0, then inverse tangent of 0 is also 0. So that's what we have there. All right, so that's what our new limits are. Notice I wrote them down here when we start doing our work. So let's go ahead and look at the work now that we've kind of done. This is all our side work, right? So the problem again is we're taking the integral from 0 to 1 over 6 of dx over the 36x squared plus 1 to the 3 halves. And so I kind of just showed some work in case any of you, need reviews over exponents. But a 3 halves power is the same thing as you can either take a cube and raise it to a 1/2, or you can take a 1/2 and raise it to a power of 3. Because when you raise a power to power, you're just multiplying. Here I'm going to do 1/2 to the power of 3 because I want to use my triangle. My triangle that I drew is a square root, which is a power of 1/2. Okay? So all I did here from this step to this step is I rewrote this as a 1/2 cubed. Okay? Next step, I rewrote this power of 1/2 as a radical. Okay, so this is just a square root here. So it's the same thing, it's just rewritten. Okay, so far it's all in terms of x, but it's a little bit neater so you can see now what we're going to be substituting. Okay, so these are the limits, like I said, changed, okay? And then notice we have dx on top here. When we did our side work, dx was 1/6 secant squared theta d theta, and that's what I have here, okay? And then we have the square root of 36x squared plus 1. When we did our side work, that was actually secant theta, right? It was the hypotenuse divided by the adjacent. So I go ahead and make that substitution here. So this entire thing becomes secant, and it's cubed. We know the trig way of writing that is secant cubed theta. So that means secant theta cubed. All right. Now everything is in terms of theta. That's what we want. Going to the next step, I go ahead and pull my 1/6 constant out to the front of my integral. Remember, you can do that. You can't move a variable out, but you can move a number. So we have our 1/6 here. And I also went ahead and noticed that we have a secant squared up here. And then we have a secant cubed down here. So that means I have two secants at the top, and I have 3 factors of secant on the bottom. So if I take away the 2 factors on the top, I'm just left with one of these on the bottom. And so that's what you're going to see in the next step. So this all reduces down to d theta over secant theta with the 1/6 pulled out. Next, this is kind of a little bit ugly, maybe not as easy to see as, notice if I have this d theta over secant theta, let's ignore the d theta part, but this is really d theta times 1 over secant theta. 1 over secant theta is the same thing as cosine theta. So we rewrite that there. So right here, instead of doing 1 over secant times d theta, it's now cosine times d theta. That's the only thing that changed from this step to this step. And then we know how to integrate cosine. We know that cosine is the derivative of sine. So the integral then of cosine is sine. And we still have our 1/6. And when we're doing our integration, we are going from 0 to pi over 4, because those were the new limits that we had. We're going to do 1/6 sine of pi over 4, so our upper limit, minus 1/6 times sine of 0, our lower limit. We have 1/6 sine of pi over 4. If you remember on the unit circle, the sine value is the y value. Okay, for pi over 4, our y value is root 2 over 2. Okay, so that's what I have there. And then minus the 1/6 sine of 0. Okay, sine of 0, when we're at 0 radians, sine of 0 is 0, right? It's the y value, okay? So that's what we have there, so 1/6 times 0. And when we simplify, we know that this guy, well, that's going to go away because that's just 0. So we're left with root 2 over 6 times 2 is 12. And we are finished with that one. All right, the next problem that was asked about was a problem similar to this. You guys should all have this on your homework, but just different variations probably of the numbers. And this again is also from section 8.4, but I'm not going to use trig substitution. I'm going to use integration by parts on this one. You want to try to use everything that's in your toolbox, what we've gone over in this entire chapter. So the integral that we're looking at is the integral of, we got the square root of 49x squared minus 100 over x cubed dx. And I'm going to rewrite this so that you can see that this is a product. If you remember integration by parts, this formula over here is taking apart what you got from the product rule, okay? Product rule is when you're multiplying, you have factors and you're taking the derivative of those. Factors that include variables of x. So integration by parts, you have the integral of u times v prime. So those are your two factors that each have at least a power of x in them, is equal to u v minus the integral of vu prime. So here we have our integration by parts formula. We have the integral of u v prime is equal to u v minus the integral of vu prime, just as a reminder. And so these two factors, u and v prime, will be under the integrand right here. Now, it's maybe a little harder to see. It looks more like a quotient, but remember, if you're dividing, it's the same thing as multiplying by the reciprocal. Okay, so you can see that there. So we're multiplying by 1 over x cubed. And we're just going to throw that under the dx. All right, so you're going to be taking the integral of uv prime, and for our integral, we need to choose our u and choose our v prime. I'm just going to rewrite that. So I have the integral of the square root of 49x squared minus 100 times dx over x cubed. So this is our other factor here. I know it looks like division, but just remember division is always the same thing as multiplying by the reciprocal. Of what's in the denominator. All right, so now that it's rewritten, you can see that this right here, this is my u, and this is my v prime, okay, according to the formula that we have up here. And I went ahead and wrote it down over here as well. So this is u, and then v prime, go down here, it's dx over x cubed. If you want to find v, we need to integrate that. So just remember that we're taking the integral of dx over x cubed, which is the same thing as x to the negative 3 dx. For an integral, you go up a power. So if I take negative 3 and I add 1, I get negative 2. You also have to divide by that power. So if I divide by negative 2, it's the same thing as multiplying by negative 1/2. And then we got our constant of integration. I'm rewriting this as negative 1 over 2x squared. Now the constant of integration we don't use in our integration by parts formula, but I just thought I'd be, write it down here, be thorough. So that's v. And then we need, let's see, the last one we need is u prime, right? So we found u, or we saw it, we labeled u. U prime, you're just taking the derivative. Remember right here, this is equal to 49x squared minus 100 to the 1/2. That's what a square root is, right? Okay, so when I'm doing the work down here, I'm taking the derivative. We use the chain rule. The outside is going to be this 1/2 power, so I take the 1/2, I multiply it to the front, and I've got the 1/2 here. Subtract 1 from 1/2, I get negative 1/2 as my new power. Leave the inside alone, and then we multiply, according to the chain rule, we multiply by the derivative inside. The derivative of this guy is just 2 times 49, which is 98x, and then the 100, the negative 100 derivative of that is just 0, so we don't need to write that. But we multiply that, and we got our dx. We're going to simplify. So if I have this power of negative 1/2, that's the same thing as throwing 1/2 into the denominator power, right? And then again, I don't have the room here, but just remember that if I have a 1/2 power of this, it's the same thing as the square root. So basically, if I have a negative 1/2 power, it becomes a square root in the denominator. So that's what we have there. And then what I did was I took the 98, and if I divide by this 2, or actually multiply by 1/2, then I get 49. So that's kind of the work that you see here. And so we have our 49x, because you have your 49x there, and this power of negative 1/2 puts all this down here. Okay. So that's a simplified version of u prime. Now we're going to take all this and we're going to plug it into our integration by parts formula. So what we end up with is I've got, the formula is uv So this was u. This is v. Okay, that's what we found when we integrated. And then minus, okay, v again. And then this is u prime here. Okay, that's what we just found. And then we can simplify a little bit. So I just slid this 2x squared underneath here. Okay, it's multiplied. I also changed this to a plus because it's a minus minus. And then I pulled out the 49 over 2 because it's just a constant. Also, notice here that we have an x and we have an x squared, so that's just going to go down a power. Okay, so we end up just with a single x that's on the bottom because of factoring out one of the x's. So we've got that there, and I believe that's the only thing that changed from this step to this step. Those are the only things that changed. And then next step, so nothing changes on this first little part, and then you have your 49 over 2. What I'm going to do now is I want to get to where I have adding or subtracting 1, right? And whenever we're doing any of these problems where we're going to do a substitution, you want to factor out if it's not a 1. So I'm going to factor out this 100. So I've got this 100 factored. And if I do 100 and factor it from 49, I get 49 over 100. If I factor 100 from 100, I get a 1. Okay, so this is with the 100 factored out. And let's go to the next step. So this is, I just rewrote this up here so we can continue. Next step, nothing changes here. And then the only change here is that if I take the square root of 100, just remember this rule that if I have the square root of, let me do it down here. Just remember this rule. If I have the square root of m times n, that's equal to the square root of m times the square root of n. So on this little section here, I just separated it. So this is the square root of 100 times the square root of all this. And you see that, so the square root of 100 is 10, so that's where that 10 came from. Okay. And then the square root of this one here is, because I want to write all of this squared, right? Well, the square root of 49 is 7, square root of 100 is 10, and then the square root of x squared is just x. And then I'm going to put those all together, and I'm going to write this as a squared. So this is the exact same thing, just rewritten, okay, because we're about to do a substitution, a u substitution. And then the minus 1, I'm not doing anything with that, okay? Then, next step, nothing changes here again. I'm going to pull this 10 out, so it's going to be multiplied by the 2 that's on the bottom, so I get 49 over 20. I've got dx over x times the square root of our 7/10 x all squared minus 1. Yeah, so not much changed at this step. And then I'm going to go ahead and do my u substitution now. Once you get to doing a lot of these problems, you'll see that when you have a square root and you've got something minus 1 and you have like an x there, that's going to be a secant, an inverse secant. So let's do that. So this next part, we're just going to write down what we have there. And we're going to do our u substitution on the second part. All right, I'm letting u equal what's in here in this little squared term. That's why I did all that work of rewriting it. Okay, and you always want to do that on these problems. So u is 7/10 x. Then we're going to solve for x. If I solve for x, all I do is multiply by the reciprocal. Okay, so if I multiply by 10 over 7 on both sides, then that gives me this right here, right? That gets me to this step that we have next. And then go ahead and take this. Okay. All right, so I'm going to end up with these cancel here, and I have x is equal to 10/7 u. And then from here, like if I wanted to take the differential, so du is going to be 7/10 dx. If I want to solve for dx, I can just multiply 10/7 on both sides, like we did a second ago. So don't really have room to do that here. I guess I can just show you on here. All right, so if I do that, these cancel and I get dx is equal to 10/7 du. Now we have enough to go ahead and substitute. So this again didn't change here. I've still got my 49/20. dx became 10/7 du, so I put that here. The x value is 10/7 u, so I replaced that here. And then I've got the square root of 7/10 x, well that's u, so u squared, okay, then minus 1. Now we're almost, and for our last step, I went ahead and wrote down this integral that you should see on your formula sheet for your common integrals that you're going to see. So we have the integral of du over u times the square root of u squared minus 1. That's actually the inverse secant of u plus c. And actually, this is supposed to be absolute value right here. Let me write that down. Okay, so when we go ahead and finally finish our problem here, notice again, this doesn't change from here to here. Our 49/20 doesn't change. This 10/7, well, that appeared in the numerator and denominator, so that can be crossed out. And then we go ahead and see that we have that inverse secant right here. So we have inverse secant of 7x/10. I don't need to write the absolute value here because 7 and 10 are positive. So just the inverse secant of 7x/10 and then plus c. Don't forget that constant of integration since this is an indefinite integral. And that completes this problem. I hope this helps, especially if you were struggling on this type of problem on your homework. Thank you for watching.